For my ML solve problem, I selected how to use machine language algorithm to identify duplications and remove the duplications from electronic health records. So I'll go over the problem in the healthcare context, the business understanding and the problem context, metrics, and the machine learning approaches and the machine design considerations. So what are the challenges, right? So duplicate records complicate data integrity in ELRs and ECRs, the electronic lab reports and electronic case reports. We need to identify if we are storing the same patient twice as a duplicate. We can use duplicate identification like machine learning models can recognize the complex patterns in data or use for identification of the machines. So what are the challenges currently faced, right? What are the challenges of having a duplicate records? We'll lose lots of resources trying to identify them. The data accuracy can be impacted, and then it can cause confusion and inefficiencies if they have to start sending notification and things like that. So let's get into the business context, right? So surveillance system often creates duplicate records and due to minor differences in incoming data entries, like, hey, Michael and Mike, are they same people or different people? Pamela and Pam, same people or different people? Robert and Bob, so things like that, right? So these can create significant issues like with data integrity, the patient safety risks and operational inefficiencies. So the system might be wasting a lot of resources. So how do they solve the current things, right? They use a deterministic approach. So they do a string comparison for first name, last name, address, and if they match, they kind of create the same patient. If not, they do it as a different patients. The problem is if there is a typo or if there is shortened names or address has a small change in zip code, they go ahead and create a new patient for that, which is not accurate. And again, we went over the business importance. So how do we want to measure, right? So we want to see how many duplicates get identified when using this new machine language algorithm. And usually when there is a duplicate, they use manual merge by an IT professional. So we want to see how many manual merges gets reduced after we go there. So let's figure out the machine language approaches, right? So we can use a lab training data. We want to do feature extraction like first name, last name, address, and see how we can handle the name variations or duplicate prediction. For example, we can use like a fuzzy match comparison, saying that, hey, there are like distance matching algorithm like Levenstein or Jaccard or something similar, which tells us that, hey, the two names, how similar are they or how distant they are, right? And when combined with other data like, hey, the names are a little different, but the last name, the date of birth, the driver's license, and the address are very similar, then the machine language can make a prediction saying that, yeah, this is the same person, even though there is a slight mismatch in the name. Again, we can use the sensitivity, specific measurements, precision, and other things to kind of see how well our model is there. Again, we can start iterative testing, fine-tune the algorithms, what fields have a major impact, what fields are actually helping us identify the duplications is what we want to check on. And we can use a cloud-based ML because the application is also cloud-based, so the latency is not a concern here, and the same way like the internet connectivity will be there, and then because they will be deploying the entire system in the cloud, so data security is not a big issue there. We probably will use an offline wherein we can train the data as needed, and then we can use batch prediction for the identifying and then giving the recommendations as needed. What are the potential risks, right? There can be a mismatch between training data and the input data in production. Like, for example, we might have to generate training data which mimics production closely and get the input from there. Otherwise, we have some problems once we get into production. So overall, what is the ML helps with improving the data quality. It helps supporting the disease surveillance system. It enhances the decision-making capability, and then we can kind of refine this as we go. That's in a nutshell how we want to use the machine language to identify duplicates and clear up the machine language algorithms in in the disease surveillance systems, which helps the disease professionals a lot. Thanks.